Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to our third lesson, Introducing Derivatives. In our last lesson, we learned the graphical definition of derivatives. Today, we will learn the differentiation of a function at a point. Are you ready? Then let us begin. Let f be a function and x naught be in the domain of f. If the limit of f of x minus f of x naught over x minus x naught as x approaches x naught exists, then if the graph of f has a tangent line at x naught, f of x naught. In that case, the line tangent to the graph of f at x naught, f of x naught, is defined to be the line through x naught, f of x naught, with this limit as its slope. For example, let us find the equation of the line tangent to the graph of f of x equals x squared minus 2 at 1, negative 1. By the definition of the slope m of the tangent line, m equals the limit of f of x minus f of 1 over x minus 1 as x approaches 1. This equals the limit of x squared minus 2 minus negative 1 over x minus 1. This can be simplified to the limit of x squared minus 1 over x minus 1. Dividing the numerator by the denominator, we find that the limit of x plus 1 as x approaches 1 equals 2. We can conclude that the slope of the tangent line is 2. Therefore, the equation of the tangent line is y minus negative 1 equals 2 times x minus 1. This means that y equals 2x minus 3. let f be a continuous function at x0. If the limit of f of x minus f of x0 over x minus x0 as x approaches x0 equals infinity or negative infinity, then the vertical line x equals x0 is tangent to the graph of f at x0 f of x0. Let us try applying this principle to our first activity. Find the equation of the line tangent to the graph of f of x equals x to the power of 1 over 4 at x equals 0.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Here is the graph of the function. As you can see, it is continuous on half-open interval 0 to infinity. Therefore, it is continuous at 0. However, the limit of x to the power of 1 over 4 minus 0 over x minus 0 as x approaches 0 equals infinity. As a result, the y-axis is tangent to the graph of f at 0, 0. Was that your answer? Well done, students. Let us continue the lesson by learning the definition of the derivative. Let x naught be in the domain of a function f. If the limit of f of x minus f of x naught over x minus x naught as x approaches x naught exists, then we call this limit the derivative of f at x naught. This is denoted by f prime of x naught. If f prime of x naught exists, then we say that g has a derivative at x naught, or f is differentiable at x naught. For example, let us find the derivative of this function at 3. To do this, we must apply the definition of a derivative. This is our expression once we have substituted the correct values. As you can see, the expression simplifies neatly. The limit of 5x minus 15 over x minus 3 as x approaches 3 gives us a final answer of 5. Therefore, we can conclude that the derivative of the function at 3 is equal to 5. Well done, everyone. Now, let us learn about the equation of the tangent line. Let f be a function defined at a. If f prime of a exists, then the graph of f has a tangent line at a, f of a. The equation of the tangent line is y minus f of a equals f prime of a times x minus a. It is time for our second activity, students. Let f of x equal x squared minus 4x. Working with a partner, Please find the values of x at which the slope of the tangent line is 0. Remember to apply the definition of a derivative.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I wonder if you managed to solve this problem. Let us say that the slope of the graph at x equals a is 0. We must first apply the definition of a derivative. After doing this, we find that the limit of x squared minus 4x minus a squared minus 4a over x minus a as x approaches a equals 0. We rearrange the numerator and factorize the terms. After canceling like terms, the expression becomes the limit of a plus x minus 4 as x approaches a equals 0. Removing the limit from the equation, we find that 2a minus 4 equals 0. Therefore, a must equal 2. If that is the same answer you found, great work! You are doing well. This brings us to the end of the lesson. Today, we have learned about the differentiation of a function at a point. In the next lesson, we will learn about derivatives as functions and the differentiation of functions over intervals. Until next lesson, thank you, teacher. Thank you, students.